Welcome to the next session on ANSYS CFD tutorials. In this session, we will analyze a 7-digit NACA aerofoil for its fluid flow analysis. We will start by double-clicking on Fluid Flow Fluent. I'll first go to Geometry and right-click. I will import the geometry of NACA 747A315 Airfoil. Then we'll go to Geometry and double-click. The airfoil which we had made is of 3D type. I will take up a 2D analysis. So I'll go to this option of extrude and delete it. You can see the airfoil is of 2D type now. It's a surface body. So here you can see two bodies and two parts. But I don't want to see the line body, so I have already suppressed it. So I can only see my surface body now. Now once you have got this, click on the XY plane look at. We'll go to sketching. We'll choose a rectangle and draw it over the airfoil. I'll go to dimensions and give dimensions to these rectangle. Also, I'll give the dimension between these two lines and these two lines. So H1 is say 200, L4 is 50, L5 is 50 and B2 is 100. Then I'll go to concept, surfaces from sketches. I'll choose a sketch 1 and apply. Operation will be add frozen and generate. Now you can see both of them have been created. So I'll go to create. I'll first go to body transformation, rotate. Body is the airfoil. So I'll select from here, apply. Axis selection is the XY plane, apply. I'll give an angle of say 10 degree. You can choose any angle which is required for your analysis. I'm using 10 degree as just an example. I'll click on generate. So you can see here this has got aligned at 10 degree now. Then I'll go to create boolean. Operation is subtract. Target body is the outer one. Tool body is the airfoil and generate. So this is the geometry of the aerofoil which is at an angle of 10 degree. Now I'll close this geometry. I'll go to mesh and double click. First I'll go to mesh. I'll choose the element size as 0.01 meter and generate. You can see here the meshing is not that fine. So I'll just go to mesh and right click. I'll insert refinement on this face and update or generate, whatever you want to choose. So you can see here the mesh has got refined. Then I'll go to this side. So I'll choose edge option. I will rename this as create name selection. Please choose that. This is the inlet. This side is the outlet. This is the top wall. So I'm renaming it as top. This is the bottom wall. So I'll rename this as bottom. And this is the airfoil. So I'll rename it as airfoil. So you can see here in name selections, all 5 of them have been created. Just go to mesh once again and update. You will get a message over here. The mesh translation to Fluent was successful. Once you get this message, your meshing is complete. So we'll close this. You go to setup and double click. Here I choose double precision, solver processes 2 and start. Here these options are to be taken note of. Solver type is pressure based, velocity formulation is absolute, time is steady, 2D space planar. First we'll go to models. The viscous model of SST K omega is already chosen, so we will continue with this one. If needed, you can change this model as per your requirement. Next, we'll go to material. The fluid is air, so we don't need to change it. We'll go to boundary conditions directly, inlet, and double click on inlet velocity. Since 7-digit aerofoil is used for a little higher speed, so I'll give here 25 meters per second and apply and close. Next, I'll go to reference values and double click. I'll compute from inlet. Reference zone is a surface body. Next, I'll go for methods. Please select the turbulent kinetic energy, second order upwind type. Then we'll go to monitors, report files. This is a choice actually. If you want to see the drag and lift on the aerofoil, only then you should choose this. If you want to only see the velocity and the pressure profile over the aerofoil, then these results are not required. But I want to see what is the value of drag coefficient, lift coefficient, what is the drag force, what is the lift force over the aerofoil. Hence, I am choosing this report file option. So I'll go to new, again select new, force, drag. So you can see here it is selected drag coefficient. I'll choose airfoil. I'll go to name and I'll write here drag space CD. I'll select print to console. OK. Again click on new, force report, drag. This time it is drag force. So here I'll write drag space force. I'll select print to console. Here I'll select the airfoil. OK. Again I'll click on new, force report, lift. Lift coefficient is selected. So here I'll write down lift space CL. I'll select the airfoil, print to console. OK. Last, new, force report, lift. Select lift force. Select your lift space force. I'll select the airfoil, print to console. OK. And lastly, I'll click on OK. You can see here all of them will be generated. So now we can close this. Then I'll go to initialization and double click. Hybrid initialization is what I am going to use. So I'll click on initialize. You can see here initialization is done. Then I'll go to calculation activities. I'll double click on auto save every iteration. Here I'll give the value as say 25. OK. Then I'll go to run calculations and double click. I'll give the number of iterations as say 250 and calculate. You can see the calculation is done. So just click on OK. We will see where the solution has converged. It has converged at the 43rd iteration. I have given number of iterations as 250, which is quite larger. But that's okay. After this iteration where the solution has converged, the calculation will anyways halt. So once we have seen this, we will go to the drag CD. You can see here the highest value is 0.0116. Next is drag force. So we'll go to the same point. The value is 4.4228 Newton, which is the highest drag force. Now let's see the CL, that is the lift coefficient. The highest value is somewhere here, you can see. So it is 0.179. You can read it from here also. 0.179. And the lift force is again somewhere here. So the value over here is already given. It is 68.55. So let's see here. So you can see here 68.5. Somewhere it will be 68.55 also. So at the 43rd iteration it has converged. So there the value will be seen. So you can see here how the value can be read from this plot, and also over here you can check once. So you will get the value. So this is the drag force and this is the lift force. You can see this column 68.55 is the highest value in this column. CL is what you can see here, and then here is the drag force and this is your CD. So you can see here the value of coefficient of drag. The coefficient of drag over here is 0.0074, but here it is 0.0116. So this is the value actually which you should hold for CD. For the drag force, again this is more, 4.42, but here if you see, obviously it is become lesser, 2.84. So for CDCL the position is a little different. You need to just check where the value is highest. So once you get these values, once this is done, we will close this. Okay. We'll go to results and double click. Click on the Z axis. So first we'll see the streamline flow. So we go to the streamline option. Okay. We'll start from symmetry 1, that is this face. Number of points, say I give as 90. And I apply. So you can see the streamline flow over the airfoil. Then I'll go to animation. I'll select the type as sweep animation. I'll select the streamline one. I'll just reduce the speed a bit. I'll remove the forever loop and I'll give it repeat 3 times. And then just animate and see. You can see here the size of the ball which is showing the fluid flow is quite larger. So that also can be reduced. We'll just go to this options here and change the size to 0.4. I'll reduce the loop to 2 and play again. So you can see here this is the flow over this aerofoil. Now please be careful that we are animating this at the velocity which we have given, inlet velocity of 25 meters per second, because this is a 7-digit NACA airfoil. Now you can see here the highest velocity is 58 meters per second over here and the minimum is 0. But one thing to notice which is very crucial is that the speed is 25 meters per second, which is quite larger as compared to the values which I have taken for the other aerofoils. I used to take 8 to 10 meters per second. But still you can see there is no vortex formation over here. The reason is it is designed to work for higher speeds. Also we have given an angle of attack of 10 degree. So once you increase the angle of attack, you can see what will be the effect on this aerofoil. So once the streamline is done, you can close this. You can remove the stick from here. You can go to contour. Okay, we'll see the pressure based contour for local range. Here I'll choose symmetry 1, number of points say 110. I'll go to render and remove show contour lines and apply. So you can see here, this is the pattern of the pressure profile. You can see here the pressure is going to be higher below because there is going to be a higher value of lift and the aerofoil is going to move above. The highest value is 504.45 Pascal of pressure. Minimum is minus 2174.93. You can see here it is minimum somewhere here and here it is maximum. So again we will untick this option. We will create another contour of velocity. Range is local. Location is symmetry 1. Number of points is 110. I'll go to render, remove the show contour lines option. Click on apply again. So now you can see this is the beautiful contour for the velocity profile. You can see here the velocity is higher because here the pressure was low. Here the value is highest, that is 58.9317 meters per second. These zones will show lower velocity. Also these lower velocities are indicating that as your aerofoil is changing its angle of attack and increasing in value, slowly there will be separation of fluid from these zones and it will slowly move towards showing vortex. But at this angle of attack, there is no vortex formation as such. So this side velocity is higher, this side velocity is lower because it is exactly opposite of the pressure profile. So with this, I end the session. I hope you have understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.